Welcome to the Cave of Science. This is the 2019 Semester 1 exam review. The review will be, the test itself is 35 multiple choice questions. You will need a calculator, and it's a Google form, so we're going to do this in B1112 on exam day. First thing to go over is your basic metric units. And again, remember, temperature is in kelvins. I don't know why they put degrees Celsius, but whatever. So make sure you review those. We also did our metric prefixes. Now, the ones we concentrated on were kilo, meaning 1,000 of something, centi, meaning 1/100th, and milli, 1/1000th. You will have some metric conversion problems, the one-steppers, such as how many meters and 5 kilometers, those type. In the non-video portion of this, there's a link for some conversion problems, or the easiest thing to do is just make up your own. So we're doing in class beginning of the school year. There will be a density problem. Again, there's 3 variables. I've got to give you 2, and you can now solve for the third one there. And also we'll have some density problems. Go over your energy transfer, convection, the transfer of energy through a gas or a liquid, conduction, the actual touching, and then radiation, the transfer of energy through space. Temperature controls, we talked about altitude, latitude, cloud cover, closeness to water. We're not going to do an adiabatic lapse rate problem, but we also talked windward and leeward, such as this diagram. On the windward side, temperature decreases as it gain in altitude, and all the moisture comes out. And then on the leeward side, temperature increases and there's no moisture. So that's why you get the rain shadow. It's warmer and drier on the leeward side. Altitude and pressure, we talked about, and you also graph this. As you go up into the atmosphere, pressure will decrease farther away from gravity, therefore the molecules can spread apart, and that's also why you get a decrease in temperature also. The layers of the atmosphere, we actually graph this and make sure you go through and review this. The troposphere where weather occurs, stratosphere has the ozone, the mesosphere, and the thermosphere. So go back and look at those characteristics and how the temperature changes. Got a decrease, increase, decrease, increase. All you gotta do is remember the decrease is in the troposphere and they alternate in every other layer. Phase change of water. In the phase change of water, as you go up in this direction, as you melt it and go to evaporation, you have that the water gains energy, therefore the surroundings lose. When you go in this direction, go into the freezing of water, you have the water will lose, so therefore the surroundings gain. In these areas where it is flat, or I should say parallel to the x-axis, this is that whole idea of latent energy, an increase or decrease in energy without a change in temperature. Notice the energy is changing, but the temperatures remain constant. Go through your global winds pressure zones. These are right in your notes. We have low pressure at the equator. This is where we have the jungles and the rainforest. High pressure is a sinking air. This is our global deserts. We have another low pressure at about 60 degrees, and then a high pressure right at the polar regions. Remember, the continental United States, Michigan, we are in the prevailing westerlies. Hence, our generalized weather flow is from west to east. Weather maps, we covered quite a bit. So go back through and make sure you take a look at the isobars. When they're close together, we have a higher chance of, higher wind speed. Here we have a cold front, so we got cold air behind it. We have a warm front pushing out cold air, and warm air is behind it. Also, make sure you go through the whole idea of the station model. Remember, cloud cover was how much of the circle was covered in. The top one is the temperature, dew point, wind direction, and then the pressure. I would go back and refer to your packet as you go through this. Dew point, point at which temperature uh, that the air condenses, the water in the air condenses. It's the bottom of clouds, where relative humidity really depends upon the temperature. As we talked about, oh, you can have 100% relative humidity in January, but it's not very much water in the atmosphere, so it doesn't feel humid, as you like to say. Dew point is the better measurement of the amount of water vapor in the atmosphere. Air masses are warm. Wet air masses come out maritime tropical out of the Gulf. The continental polar are our cold, dry ones. And actually, Wednesday, we're going to get this blast of continental Arctic. I think it's only supposed to be in the teens on Wednesday. Cold air masses come to the south. Warm air masses come from the, or go to the, cold air masses go to the south, or warm air masses will flow to the north. And we know in the northern hemisphere, everything shifted to the right because of the Coriolis effect. Waves, again, we talked about really two general ones, longitudinal and transverse. Make sure you review those. The EM spectrum, really the thing to remember here is the longer the wavelength, the lower the frequency. The lower the frequency, the less energy. The shorter the wavelength, the higher the frequency, the higher the energy. And remember, when you talk about waves, we're going to calculate wave speed. Again, I got to give you 2 out of the 3. So wave velocity, wave speed equals frequency times wavelength. If it is an electromagnetic wave, the velocity is known and is 3 times 10 to the 8th meters per second. That is a constant. So for a electromagnetic wave, the velocity is 3 times 10 to the 8th meters per second. This is the whole idea where we use the EE key. And we'll be doing some of those problems also in class. Go through your mirrors. Plane mirror, the angle of incidence equals the angle of reflection. Our curved mirror is concave, convex. This one's used for magnification. This one gives you a greater field of view. Our concave and convex lenses. Our convex is our eye, and it also gives you a magnified image, and a concave lens spreads the light out. We also talked about light. You can only do 2 things when it strikes the surface. It either reflects or absorbs. And if it reflects 80%, that means it absorbed 20%. So make sure you go back and review that also. This is that whole paper one we did with the white, black, and the green paper. The Doppler effect, as the object approaches a person or you, it has a tendency to shrink its wavelength, so therefore the frequency goes up, and for sound, it's a higher pitch. As it moves away from you, you can see the wavelength gets longer, so therefore frequency will go down and the pitch will get lower. Same thing happens for light. As it moves away, it's called the red shift. As it moves towards, it's referred to as the blue shift. And that's it. So if you have any questions, you go through this. You know, we got a week and a half here before the exam. So we will see you in class.